Something soft, almost shapeless, slips through a gap no wider than a coin, pauses as if thinking, and then rearranges its entire body to fit somewhere it clearly shouldn't. A few seconds later, it is gone. No sound, no trace, just the faint movement of water. You might think you just watched instinct. But then it comes back, carrying something it plans to use later. That's where the certainty breaks. Because instinct doesn't usually look like preparation. And preparation suggests something else entirely. Not human thinking, not even close, but not simple either. Somewhere in between, or maybe somewhere completely different. Long before cameras captured these moments, coastal communities already told stories about the octopus that didn't quite fit the usual categories of animals. In parts of the Mediterranean, fishermen described creatures that watched them back, not just reacting, but observing. There are old records from naturalists in ancient Greece, people like Aristotle, who wrote about octopuses changing color and slipping through traps, already hinting that these animals didn't behave like the rest. At the time, knowledge of the natural world was limited, yet even then, the octopus stood apart. It wasn't just its body, which lacked bones and seemed almost liquid. It was the way it interacted with its surroundings. Nets would be carefully avoided. Bait would sometimes be removed without triggering traps. These weren't isolated observations. Over time, patterns appeared. Centuries later, in coastal Japan, similar impressions emerged. Fishermen developed techniques specifically adapted to outsmart octopuses because ordinary methods didn't always work. There are accounts of octopuses unscrewing jar lids, long before controlled experiments confirmed this behavior. At first, these stories sounded exaggerated, but eventually people started paying closer attention. By the 20th century, marine researchers began documenting what earlier cultures had only described. In laboratory settings, octopuses didn't just react, they explored. They pushed objects, tested boundaries, and sometimes repeated actions with no immediate reward. That last part raised eyebrows. Because in the animal world, behavior without a clear survival benefit is unusual. One experiment involved placing an octopus in a tank with a simple jar containing food. At first, the animal would struggle. Then it would learn. Not by accident, not randomly, but with increasing efficiency. Soon, it would open the jar quickly, almost casually. But what caught attention wasn't just the success, it was the method. Each individual octopus approached the problem differently. Some used strength, others used precision. There was no single, correct way. That kind of variation starts to feel familiar. It resembles problem solving, not just conditioned behavior. And yet, everything about the octopus seems built against that idea. No long lifespan, no complex social groups. No need to cooperate or compete within structured hierarchies like mammals or birds. Most intelligent animals we know, dolphins, elephants, primates, share one thing: social complexity. They need to remember relationships, anticipate actions, negotiate. The octopus doesn't. It lives alone. It doesn't raise its young. It doesn't form lasting bonds. From an evolutionary perspective, there's no obvious pressure pushing it toward advanced cognition, and still, it's there. That contradiction is where things start to get interesting. Looking closer at its body, the first surprise appears almost immediately. The octopus doesn't rely on a single central brain the way we do. It has one, yes, but that's only part of the story. A significant portion of its neurons are distributed across its arms, not just connected, but semi-independent. Each arm can process information, react, and even make decisions locally. Imagine touching something and not needing to think about it consciously. Your hand already knows what to do. Now imagine that happening 8 times at once, each with a level of autonomy. Early researchers struggled to interpret this. It didn't fit the usual models. Behavior that seemed coordinated could actually emerge from decentralized processes. The octopus wasn't controlling everything step by step. It was setting general directions while the details unfolded across its body. That changes how you think about intelligence, because if decision-making isn't centralized, then what exactly is doing the thinking? Observations from the field added more layers. In Indonesia, divers recorded an octopus collecting coconut shells, carrying them awkwardly across the seabed, and assembling them into a shelter when needed. Not immediately, later. That delay matters. It suggests anticipation. The animal wasn't just reacting to danger, it was preparing for a possibility. Some researchers hesitated to call it planning. The word carries weight, but it's hard to ignore the sequence. Find object, transport object, store object, use object when necessary. There's a chain there, a structure, and it's not the only one. In aquariums, octopuses have been observed leaving their tanks at night, moving across dry surfaces, entering neighboring tanks to feed, and then returning before morning, not once, but repeatedly. Staff would arrive to find missing fish and no obvious explanation, until surveillance footage revealed the pattern. It wasn't random wandering, it was targeted behavior. There's something unsettling about that. Not in a negative sense, but in the way it disrupts expectations. You don't expect an invertebrate to behave like that. You don't expect intention to show up in such a form, and yet it does. By this point, the question isn't whether the octopus is intelligent. It's what kind of intelligence this is. Because whatever it is, it didn't follow the path we're used to seeing. And maybe that's the part that stays with you. Not that it's smart, but that it became smart in a way that feels almost unrelated to everything else. Touch something in the ocean, and for most animals, it's just contact. For the octopus, it's closer to tasting. Each arm is lined with hundreds of suckers, and each of those can detect chemical signals. That means every surface carries information, not just shape or texture, but composition. A rock isn't just a rock. It has a chemical signature. So does prey. So does danger. This creates a kind of perception that's hard to picture from a human perspective. Vision matters, yes, but it isn't the only channel. Information flows through the entire body, continuously. Instead of a single viewpoint, there's a distributed awareness. That alone would already set the octopus apart. But then there's the visual system itself. Its eyes resemble those of vertebrates, camera-like with lenses and retinas, yet they evolved independently. That's not a shared inheritance. It's convergence, different evolutionary paths arriving at similar solutions. There's a small detail hidden in that similarity. Human eyes have a blind spot where the optic nerve crosses the retina. The octopus doesn't. Its wiring avoids that interruption. It sees without that gap. It also detects polarized light, something humans can't perceive. In underwater environments, where light behaves differently, that ability can reveal patterns invisible to us, edges, movements, contrasts that would otherwise disappear. So now you have an animal that can taste with its arms and see aspects of light we can't even imagine. Then it changes its skin, not slowly, instantly. The surface of the octopus is filled with tiny pigment sacs called chromatophores. These expand and contract under muscular control, revealing or hiding colors in fractions of a second. Beneath them, other cells reflect light, adding brightness and iridescence, but color is only part of it. The skin itself shifts shape. Smooth becomes rough, flat becomes ridged, spikes appear then vanish. The animal doesn't just match the color of its surroundings, it matches the structure. A patch of coral isn't just imitated in tone, it's imitated in form. From a distance, it disappears completely. Here's where things get strange again. Evidence suggests that octopuses might not perceive color in the same way humans do. The exact mechanism is still debated. But it raises an odd possibility. The animal may be adjusting its appearance without experiencing color as we understand it. Some hypotheses propose that its skin itself plays a role in sensing light, not just responding, but detecting. That would mean perception isn't confined to the eyes. If that sounds unusual, it's because it is. Most animals process sensory input in a centralized way. Signals go in, decisions come out. The octopus spreads that process across its body. Input and response blur together, and this influences behavior in ways that are easy to miss if you're expecting something familiar. Take problem solving again. In controlled experiments, octopuses can navigate mazes, recognize shapes, and remember solutions. They can distinguish between different human handlers, reacting differently based on past interactions. That last part suggests something more than simple conditioning. It points to recognition, linking experience to individuals. There's also the matter of play. In captivity, some octopuses repeatedly interact with objects that offer no clear reward. They push them, release them into currents, then retrieve them again. Not once, but over and over. Play behavior is often associated with animals that have spare cognitive capacity, time and energy to explore beyond immediate needs. Seeing it in a solitary mollusk forces a rethink, because now the pattern doesn't match the usual explanations. No social pressure, no extended lifespan, no parental learning, and still complexity emerges. One possible explanation comes from the environment itself. The ocean floor, especially in reef systems, is unpredictable. Crevices, shifting light, hidden predators, mobile prey. Nothing stays the same for long. Survival depends on flexibility. A rigid response wouldn't work. A fixed strategy would fail. So instead, the octopus adapts in real time. Its body allows it to access tight spaces. Its perception allows it to interpret subtle cues. Its distributed nervous system allows rapid, localized reactions. Put all that together, and you get something that doesn't need a single, overarching plan. It operates through constant adjustment. That might be the key difference. Where human intelligence often builds structures, language, systems, long-term plans, the octopus seems to operate in the present, but with a depth of processing that gives it room to improvise. Not shallow, not reactive in a simple sense, just immediate. And maybe that's why it feels so unfamiliar, because it doesn't mirror us, it doesn't try to. There's a moment watching an octopus move where the question shifts. It stops being, how does it do that, and turns into something quieter, something harder to phrase. What counts as thinking? For a long time, the answer leaned heavily toward human traits: language, abstraction, long-term planning, social interaction. If an animal showed pieces of that, it earned a place on the scale. If it didn't, it stayed lower. The octopus doesn't fit neatly anywhere on that scale. It solves problems, but not always in predictable ways. It remembers, but doesn't build societies. It interacts, but doesn't form lasting relationships. Its intelligence isn't missing pieces. It's arranged differently, and that difference matters, because it suggests that intelligence isn't a single path. It's not a ladder with fixed steps. It's more like a set of solutions shaped by specific conditions. For vertebrates, especially mammals, complexity often comes from social demands, cooperation, competition, alliances. Navigating those requires memory, prediction, communication. For the octopus, the pressures are different. No shell for protection, a body that can be injured easily, a habitat filled with narrow spaces and constant threats. Every moment requires assessment. Every movement carries risk, so instead of building long-term structures, it builds flexibility. It doesn't need to plan years ahead. It needs to adapt right now and do it well. That might not look like intelligence at first glance, but when you see the outcomes, it's hard to dismiss. There's also a broader implication that's easy to overlook. If intelligence can arise in such a different form here on Earth, within a lineage so distant from ours, then there's no strong reason to assume it would resemble us elsewhere. For decades, ideas about non-human intelligence often defaulted to familiar traits: technology, communication, recognizable signals, something we could decode. But the octopus shows that intelligence can exist without any of that. It doesn't build tools in the conventional sense. It doesn't create structures or symbols. And still, it navigates a complex world with precision. That expands the definition, not by adding more traits, but by loosening the boundaries. And once those boundaries loosen, the question becomes less about comparison and more about recognition. Can we identify intelligence that doesn't resemble our own? Or do we overlook it because it doesn't match expectations? The octopus doesn't answer that directly. It just exists, doing what it does, quietly challenging the framework. There's something else too. Most octopuses live short lives, a few years at most. They don't pass knowledge across generations in the way social animals do. Each individual starts almost from scratch, and still, each one develops these capabilities. That suggests a strong genetic foundation, combined with rapid learning. It's not culture, it's not tradition, it's something built into the structure itself, and then expressed through experience. At this point, the idea of intelligence starts to feel less like a single concept and more like a category we've been trying to simplify. Maybe too much. Because once you see how different it can be, it's harder to keep using the same definitions without questioning them. And that question doesn't really go away. If you've made it this far, I'm curious about something, not in a leave a comment kind of way. More like this: what part stayed with you? Was it the way it moves, the way it solves problems, or just the fact that something so different can still feel aware in its own way? People notice different things, and those differences are interesting on their own. If you've ever seen something in nature that made you pause like that, even briefly, I'd like to hear about it. Not polished, not perfect, just what you remember. And if this kind of story is something you'd want to keep exploring, you already know where that button is. No pressure, just an open door if you feel like coming back.